Okay, hey everybody. So lecture today, I didn't quite make it to the end, which is the section on stacks. Um, so here we go. A stack is a data structure, and it's got two methods, which are push and pop. I been using the term stack all term because it's synonymous with automatic memory allocation in C. We'll talk about that point later. Right now, I just want to talk about the data structure piece. And so there's a picture here of a stack of trays. And so the idea is you don't take out trays from the middle, you don't put trays on the bottom. Your only option is to put a tray on the top or take the tray off the top. And so to push is to put a tray on the top, and to pop is to take one off. And this actually is a lot like the array that we looked at in today's class, except for the array didn't have a pop, it only had a push. Sometimes there's a third method, which is called peek, and that says show me what's on top, and then but don't take it off. So there's really no way to get to anything below this top green tray, except for to take it off and then look at the one beneath and the one beneath and so on. Stacks are not one of the simpler data structures. They don't always have great properties, but I guess for the things it does really well. So here's an example of a stack of integers, and so this is code for you to implement. Again, it's going to look a lot like the array, the fetch store array that we looked at in today's class. And so I think I put this in the prompt. Each of these is only a few lines of code to implement. What are the data members? How do you initialize it? How to push and how to pop. Here's an example of using it. So I allocate a stack. And again, I had mentioned before, we wanted to lecture on being genericity, being generic, and we're doing that for 3A. It's important to understand how all these data structures can be generic. But for this assignment, we're actually going to be quite specific. We have a specific data structure, which is a stack, and we're working on a specific data type, which is an integer. And so your data members here should take integers, and then you see the interface here. What we're pushing onto the stack is an integer, and what we're popping from the stack is also an integer. And so we make a stack, we initialize it, we push 5, we push 6, and then we pop it, and we print what we popped, and it better be 6, which is the last thing that we put on. The tray we just put on top of the pile. We push 7, we pop, that's a 7, and then we pop again and we get a 5. And if we did another pop, I guess we'd get an error message. So in terms of asymptotic complexity, well, the push is O of 1. It's constant time. The pop is O of 1. I guess storing, that's pushing, is O of 1. The fetch is really slow. If you want to fetch, you'd have to pop every element out, put it somewhere, and then put them all back. So maybe you could use another stack to put them all in as you take them out and put them back. But it's not really meant for that. Good. So project 3B, you're going to implement a stack. Here's the stuff where I talk about lines of code. My stack struct has two data members, one of which is an array, another one is a counter. My initialize is 1 line of code. My push is 2 lines of code. I have 5 more lines for error checking. My pop is 2 lines of code. I have 5 more lines for error checking. So that part, not too bad. The other part is going to do a little thinking. So we are going to extend your project 2E to work the way that calculators actually used to work pretty commonly. It's referred to as reverse Polish notation. And the idea is where if we were entering in a calculator, we'd say 3 plus 5. With reverse Polish notation, you'd say 3, 5, and plus. If you have this with the traditional notation, 3 minus 4 times 5, there's 2 ways to parse it. One would be 3 minus 4 times 5. The other would be 3 minus 4 times 5. Sorry, I said the same sentence twice. Hopefully you're all following along that there were parentheses, and I said the things in the parentheses a little quicker. I think we would all assume that we mean the latter here because we assume that multiply has precedence above subtract. Um, but there is an ambiguity, and so with reverse Polish notation, that ambiguity does not exist. And so the idea is to take your 2e. You're going to get arguments like this, and so as you're calling a dot out, this would be 3 would be argv of 1, 4 would be argv of 2, minus would be argv 3, 5 would be argv 4, and the x would be argv 5. And you would walk the arguments, and if the first character is a number, well, you'd call your routine from project 2e, and then if you found, for example, a minus, you would pop two things from the stack, do the minus, and then push it back. And so, again, if you saw 3, 4 minus, you'd do a pop, 3 minus 4, that would return minus 1, and then you'd push minus 1 on the stack, push on 5, and when you got a times, you get minus 1 times 5. And the prompt, I've posted a link to a website that I thought was really helpful in figuring out kind of how to implement it. They have it written in a way that is for someone who's doing a project like this. So that's it. Good luck on Project 2B. I think it's a fun one, and I hope people enjoy doing it. I'll see y'all soon.